Okay, hope everyone had a good weekend and did well on the test. I'll grade them. We'll have the test results back after Thanksgiving. So you'll see those, and then we'll go over them. Monday and Tuesday class, we'll go over them that first Monday back after Thanksgiving. For Tuesday, for the Thursday, Friday kids, you'll do it the Thursday you get back. So we're going to start now with working with triangles. I've been talking about how this is going to be like the big unit as we go through it. A lot of the stuff we've learned we're going to be able to do now in triangles, and we're just going to go from there and see where we go. So for a warm-up, I want you to take a few minutes, try to work through these problems. Stuff you should know, the basic rules you know about triangles. You should be able to do most of these problems. The last one might be a little more difficult for you, but it is something that, with what we learned last unit, you should be able to get that, I think, if you kind of understand what's happening. So take a few minutes to do that. Okay, so we kind of look at what we're looking for. If we all remember, I think we remember back from everything we've learned about triangles. Triangles measure 180 degrees. All their angles add up to 180. So when we're trying to figure out what the question mark angle is, we'll just kind of add 64 and 42 is 106. So 180 minus 106 gives us 74 degrees. So this angle is 74 degrees. Hope everyone was able to do that one. Similar problem here. We got two angles. We're trying to find the third one. 65 and 70 is 135. So that makes this angle 55 degrees. Sorry, not 55, 45. My bad. 45 degrees. Hope everybody did better on that one than I did. Okay, now we're just solving for x. So we're trying to figure out what that last angle is. Again, I know that everything adds up to 180, so 133 plus 26 plus x plus 28 is going to equal 180. So when I add up all my numbers on one side, I get 123 plus 26 is 149. 159. Yeah, that's 159, sorry. Plus 28 plus x. So this works out to 187 plus x equals 180. So x is going to equal -7. Type of problems we can do in the geometry stuff when we're working with the algebras. You might end up solving for x might be a negative number, but it is something that needs to work to get our answers. So just to check it, -7 plus 28, this would be 21. So this angle is 21 degrees. So 21 plus 26 is 47, plus 133 is 180. So yes, -7 is our answer. Again, here we're trying to find the measurement of angle A. So we're told that angle A equals 2x plus 10. We know I'm looking at this triangle is what I'm looking at. I'm going to kind of outline it in red. So we're looking at this triangle to find out what my angles measure. So I know one angle they tell me is 2x plus 10. So I have 2x plus 10 plus I have two other angle measurements that they've given me that look like they're vertical angles. So I have this angle and 115, so that's going to be 115 because vertical angles are congruent. This angle and this angle are congruent, so that's going to give me another 2x plus 7. And all that's going to equal 180, like I said. So now we're just going to go through and we're going to combine all like terms. 2x plus 2x is 4x. 10 plus 115 is 125, plus 7 is 132. That's going to equal 180. Subtract 132 from both sides. That leaves me with 48 over here. So 4x equals 48. So I'm finished. X is going to equal 12. So now I plug 12 in here. 2 times 12 plus 10. So angle A is 34 degrees. Make sense? And then obviously we plug 12 into the other angle, we get that angle is 31 degrees. So 31 plus 35 plus 34 is 65, plus 115 is 180 degrees. So hopefully everybody was able to do that. It is something we're going to kind of reiterate in a minute here, that all triangles angles measure and add up to 180 degrees. Okay, moving on. Sorry. So the angles of triangles, we get the triangles theorem, like we just said. The sum of the measures of the angles of a triangle is 180 degrees. So in our diagram, the measure of angle A plus the measure of angle B plus the measure of angle C is going to equal 180 degrees. It's one of the basic fundamentals of geometry, that triangles equal 180 degrees when you add all their angles together. So what we got to prove, we're doing proofs now. So we're going to prove that the measurements of the angles equal 180 degrees given our triangle. So one thing I want to talk about is, if you look at our diagram, is we've kind of drawn in this dotted line. We have this dotted line kind of going through point A. If you remember in our last unit, we were talking about we can make through any 2 points, we can draw our line. So what we've done is we've actually drawn this line in to be parallel to the side of the triangle BC. It's something that we are going to have to do in some of our proofs with triangles and as we move forward. So I just kind of want to introduce that to you right now, that it is something that you have a diagram, you may have to add lines to the diagram to figure out ways to be able to prove certain parts of the proof. So we're going through our proof. We're given triangle ABC, that's our given. So we've drawn in our line, that's our second step. Draw AD through point A, that's parallel to line BC. What we can do for that is the parallel postulate. Through any point, there's only one line that's parallel to any given line. So that's what we did. So now from there, we need to start talking about what we're looking at. So we're going to talk about angles 4 and angle BAD, which is the big chunk of that linear pair there. They form a linear pair. So we're looking at angle 4 here. Make it a different color. Give me a minute. I'll do it in green. So we have angle 4, and then this angle here is what we're talking about forms the linear pair. That big angle. Hope everybody can see that. So now we have that form a linear pair. Again, that's the definition of a linear pair. We have a line with an angle coming off of it, so that's the format. From there, we also know that angle 4 and angle BAD are supplementary. Again, definition of a linear pair. Or if two angles form a linear pair, then they are supplementary. So remember, linear pair angles are supplementary because they have to add up to 180 degrees, because that's what the actual angle of a straight line is. Okay, so line 5 now we go. Telling now, measure of angle 4 plus the measure of angle BAD equals 180 degrees. Again, definition of supplementary angles. If they're supplementary, they have to add up to 180, so their measurements are going to equal 180 degrees. Okay, what do we think our next line is? Next line is the measure of angle BAD is made up of those two smaller angles, angle 2 and angle 5. So now we have measure of angle BAD equals the measure of angle 2 plus the measure of angle 5. That is the angle addition postulate, which we all should have known and had for the tests yesterday or Friday. Our next line then is where I've substituted BAD for 2 and 5. That's our substitution theorem or property. So now we're telling us that angle 4, angle 2, and angle 5 equal 180 degrees. So we now have a similar setup to what we want to have in our proof, and we even have angle 2 in our line here, so we're actually looking pretty good. Okay? So now we go to our next line. We have measure of angle 4 is congruent to the measure of angle 1, and the measure of angle 5 is congruent to the measure of angle 3. If we kind of look, we have parallel lines, 2 different transversals. So here we're dealing with the alternate interior angle theorem. We see that angle 1 and angle 4 are on opposite sides of the transversal. They're inside the 2 parallel lines, so that makes them the alternate interior angles. So they are congruent. So from there, we're able to say that the measure of angle 4 equals the measure of angle 1, and the measure of angle 5 equals the measure of angle 3, for the definition of congruent angles. And then our last step is, again, just substitution to put angles 1 and 3 into our proof. to show us that they equal 180 degrees. These are the types of proofs we're going to be working on in triangles. We're not going to do a ton of them. I'm not going to kind of bog you down with all the proofs in this unit. But we're definitely going to see them either in our notes section to prove the theorems, or maybe as 1 or 2 problems on homeworks, and there will definitely be 1 or 2 on the test, because this is kind of now the nitty-gritty of doing proofs and proving triangles are congruent. Okay. So at each vertex of an triangle, the angle formed by one side and an extension of the other side is called an exterior angle. So if we have our triangle drawn in here like this, we're going to call it triangle ABC. What we're talking about is one side. So if I'm looking at side AC, so I'm looking at angle A. So I'm looking at this angle. If I extend line AB, that makes this now what they're calling the exterior angle. And our exterior angle theorem, sorry, I drew in the thing, is if the measure of an exterior angle of a triangle is equal to the sum of the measures of the 2 remote interior angles. So if we think about that, what we have is our angles here in angle A, the exterior one, which is this one in blue now, and the angle inside the triangle, they form a linear pair that's 180 degrees. Well, we know the angles of the triangles have to equal 180 degrees. So if angle A doesn't change and that stays what it is, then this here has to equal B plus C. Hope that makes sense. I hope everybody sees that. That's what we're looking at when we're talking about the exterior angle theorem. The big thing is just remember that it's a linear pair. The triangle at the vertex and the exterior angle form a linear pair, so it's always going to be 180 degrees. Okay. Oops, went too far. So our example, we have example here. We've given triangle RST. We're given 2 angle measurements, a 60 and an 80 degree angle. We're asked to find the measure of angle 1. So if I look at it, 60 plus 80 is 140. So that tells me angle 1 is going to be 140 degrees, which makes sense because our angle here at T, this angle has to be 40 degrees because the angles of the triangle have to equal 180. Does everybody see that? Does that make sense? Okay. Moving on. Your turn. 7 problems here. Take a few minutes, go through the diagram. The diagram on the first 6, we're trying to find the measurements of those 6 angles. They're all labeled and numbered inside the diagram. It's a little tricky, making sure we kind of go through. You're not going to do them all in the order that they're given. You're not going to go 1, 2, 3, 4, 5, 6. You're going to have to kind of jump around a little bit to get them. And then again, we have another one, which is just trying to find the measurement of angle A there. It's not an exterior angle, it's just another interior angle. So make sure that that's the last one. Yep, that's the last one there. So take a few minutes and then come back and look at the answers. Okay, so we've kind of gone through and we're going to figure angle 1 first. Let's kind of take a look and see if there's anything I can quickly find and see what the angle measurements are. Can't really see anything here exactly that's jumping out at me that, oh, it has to be that. So we're going to start with angle 1. So angle 1, where it's an exterior angle, I know it has to be the sum of 68 plus 36. So that is 104. So that makes angle 1 104 degrees. Does that make sense? Think of it this way. If we're trying to figure out the angles of the triangle, it's still 180 minus 68 minus 36. So that's going to tell me that this angle here in the red arc is going to be 68 minus 34 gives 104. So that's 180 minus 104. That equals 76 degrees. So that makes this 76. Again, we have our linear pair, so that makes angle 1 104. Okay, from there, we're going to jump around and move on. Not quite going to do angle 3 yet because I'm not really sure exactly what it is. I see that it's on inside here, but I'm going to look at angle 4 first because I see definitely angle 4 is part of a 3-angle grouping that forms a linear pair there. So if I do angle 4, equals 180. 70 plus 65 is 135. So that means that angle 4 is 45 degrees. Does everybody see that? Okay, so I can jump to angle 4 is 45. What I'm going to do is I'm going to kind of fill these in different colors here. So this is 104. This one here is 45. Okay, let's go back to red. So now again, I see that that's 45 degree angle. So now I can look at angle 3 that we'll do in purple. Angle 3 is on this linear pair. Not really a pair. It's a group of angles that form that linear angle, that straight angle. So now angle 3 is going to be 180 degrees minus 115, which is angle 70 degree angle plus 45. So that makes angle 3 65 degrees. Does everybody see that? Okay, hope everybody saw that. Okay, so now I have 3 of the 6 angles pegged, kind of looking and see where we got. Let's look. I can probably do angle 2 now. Yeah, we can do angle 2 because when I look at the picture, I have one angle measurement of this triangle where angle 2 is, this 65 degrees. I see here, this is a vertical angle. So this angle here is 36 degrees. So that tells me angle 2 is going to equal 180 minus 65 plus 36. What's that? 101. So that tells me angle 2 is 79 degrees. Does that make sense to everyone? Okay. Hope everybody saw that. So now we got 2 left. Angle 5 and angle 6. Kind of looking at them, they look kind of difficult. Angle 6 is the fewer steps, so we'll look at that one next because I see that it's on a linear pair here. It's an exterior angle to that angle and that triangle here. So this angle is going to be 180 minus 82 minus 65, which if that, my math is correct there, tells me that that is, actually, I'm doing that incorrectly as well. Didn't need to do that. I just need to add 65 and 82 together because the exterior angles are the sum of the 2 opposite angles, or remote angles as they're called. So angle 6 is just 65 plus 82, which is 147. So angle 6 is 147 degrees. Sorry about the confusion there. So now angle 5 is the last one we're looking at. I have an exterior angle here that's 118. So that lets me know that this angle internally here is going to be 62 degrees. So angle 5 is going to be the difference of 180 minus 62 minus 45. So 62 plus 45 is 107. 180 minus 107 is 73. Hope everybody was able to get all those done. We're able to recognize where we were going for that. Again, that's a really good problem. You can see a similar problem like that on a test. Kind of plug in some numbers in, and we may even throw some algebra in there to make it a little more difficult, a little trickier. But again, it's something we can look at and see, yep, that's how we have to do that. So now we're trying to find the measurement of angle A again. So I'm trying to find this angle. Again, when I kind of look at what I have going on here, I don't know from what I have what it's going to be, but I do know that I have a linear pair here. So this angle here is 120 degrees. Did everybody see that? Hope everybody sees that. So now I know, again, triangles add up to 180. I have 120. Angle A is x plus 36. The other angle that we don't have is a vertical angle for that. So my other angle that I need to add in is x plus 46. So again, we do our math, we combine all our like terms. 180 is going to equal 36 plus 46 is 82. 120 plus 82 is 202, plus 2x equals 180. I subtract 202 from both sides. Again, remember, it is possible to get negative numbers for x. We're not solving for x, we're just solving for the angle measure. You can't have an angle measure be negative, so if you end up with a negative angle measure, you did something wrong. But if you end up with a negative x value, that might be okay. So I have 2x equals negative 22, divide by 2. So x equals negative 11. So x plus 36 is really negative 11 plus 36. That equals 25 degrees. So angle A is 25 degrees. So if I kind of plug that in, 25 plus 120 is 145. That's going to make that 35, that angle there. If I look, negative 11 plus 46 equals 35. So that works. So we have the right angle. Right. Again, we're able to check our math. So we're good. Hope everybody saw that, kind of understood what we were doing there. Again, typical problems we can work with angles and triangles in algebra and kind of get everything worked in together. All right. So there are two corollaries when we're talking about the angle sums. The acute angles of a right triangle are going to be complementary. Because think of it, if it's a right triangle, one of the angles is 90 degrees, so the other two angles have to add up to 90. We can't have more than one angle, more than one right angle in a triangle, which comes into our second corollary there, that there can be at most one right or obtuse angle. That should be or. So we can only have one right or an obtuse angle in a triangle. So think of it, you can't have a triangle with two right angles. That's the right angle. Here's my second right angle. That's not a triangle, that's the start of a square. Same thing if you have an obtuse angle. You can't have another obtuse angle because it's never going to be a triangle. So it makes common sense. What corollaries are kind of subsets of theorems. They'll work from a theorem based on what you're given for theorem information, and then you can kind of make some other hypotheses that you can prove that become corollaries. Does that make sense to everyone? Okay. Congruent triangles. Now we're going to get into what congruent triangles are. So we talk about corresponding parts. So when they talk about a congruent triangle, is that the polygon, we're going to start with polygons too, because it applies to all polygons, not just triangles. Remember we did that whole unit on transformations with the reflections and the rotations and the transpositions? That's what we're looking at here when they talk about mapped exactly onto another figure are congruent. So polygons are congruent. We can look at our example, the picture. Polygons are congruent if and only if, big words, all pairs of corresponding angles are congruent and all pairs of corresponding sides are congruent. So we're given our figure angle, triangle ABC is congruent to triangle RST. So what we're looking at is we've kind of have it all filled in. You got to kind of make sure as we're working with it, you're going to start seeing all these slashes. So it's 1 slash, 1 slash, those sides are congruent. So if we're listing our sides, which is what you'd be asked to do, we can write AB is congruent to RF. Again, you got to make sure you're using the right letters first. We have the narrow angle here is A, so we have to use that same corresponding angle. What we can also say is angle A is congruent to angle R, because they're the same thing. So again, we can kind of finish this up. BC is congruent to ST. Then would have, what's that? Let's call it CA is congruent to TR. And then angle S is congruent to angle B. And angle T is congruent to angle C. So that would be another problem you're going to be asked for in homework or on a test. Here are two congruent triangles. Name all the corresponding parts. Does that make sense? Okay. Again, we have our example. Name the pair of corresponding parts. What's our next one? Okay, yeah. So take a few minutes, kind of go through this and name all your corresponding parts. Remember, even though you only see slash marks on 2 of the sides on each triangle, we're still going to say that everything's congruent because we're told everything's congruent. So go through and name all your corresponding sides and come back and check your answers. Okay, so we'll start with the easy stuff, the 1 slash marks. They're telling us that those 2 angles are congruent. So we have side TS is congruent to side ZY. Again, letter order makes a difference. I started with the obtuse angle, so I did the same thing on the other triangle. Next one, we have XZ is congruent to RT. Again, I use the acute angle as the first letter, so that's what I'm going to do there. So because those 2 sides are congruent, the triangles are congruent, we can also say that XY is congruent to RS. Does that make sense? So all our sides are congruent. Because all the sides are congruent, we can then say again that all the angles are congruent. So angle Z is congruent to angle T. Angle S is congruent to angle Y, I believe. Yes, Y. And then angle X is congruent to angle R. So kind of think of it, you might have to flip your paper to kind of put the orientation in the same position for you to figure it out. But just remember, like with the reflections and the transpositions and the rotations, that's what we're looking at to try to figure out how to get this sorted out. Okay. So our phrase, if and only if, is very important. It tells us that both the conditional and the converse are true. So if we're told 2 polygons are congruent, then we know that their corresponding parts are congruent. If we're told that the corresponding parts are congruent, if the sides and angles are congruent, then we can say that the polygons are congruent. So what that actually comes out to be is the corresponding parts of congruent triangles are congruent. This is a theorem, and it is a reason and it's a reason we can use in our proofs. So rather than writing out this big long thing, we're going to abbreviate it to CPCTC. As we're doing our triangle proofs, that is going to be your friend. When we start seeing some stuff, if we're trying to prove triangles are congruent, or we're trying to prove that parts of a triangle are congruent, we're going to be using that reasoning a lot. Okay, so the third angle theorem. What this tells us is if 2 angles of one triangle are congruent to 2 angles of a second triangle, then the third angle of those triangles on each triangle, they're congruent as well. So it can't be just 2 and not have a congruent one, because when you think of it, the angles all have to equal 180 degrees for the triangles. If 2 angles on each triangle are congruent, then the third angle has to be congruent because they have to add up to 180 degrees. Hope that made sense. And then just like we had in angles and segments, we have the properties of triangle congruence. Again, reflexive property. Triangle ABC is congruent to triangle ABC. The symmetric property, triangle ABC is congruent to EFG. Then triangle EFG is going to be congruent to ABC. And lastly, the transitive property, if triangle ABC is congruent to EFG and EFG is congruent to JKL, then ABC is congruent to JKL. So I've seen that before. We're going to see it again. I hope it all makes sense because it's something we're going to need as we go through our proofs. Okay. 2-column proofs, triangle proofs. These are what everybody wants to see and what we're going to be working on. So we're told some stuff. And this is where I talk about mark up your picture. We're given AB is congruent to CB. 1 slash mark. AB congruent to CB. Next, AD is congruent to CD. 2 slash marks. Because they're 2 different measurements. So they have to be 2 slash marks. Then angle BAD. So we look at angle BAD, the 1 arc is congruent to angle BCD, again 1 arc for those angles. And then we're told that BD bisects angle ABC. So we look at angle ABC, so that bisects. So what do we remember about angle bisectors? That's right, angle bisectors divide the angle into congruent halves. So it divides the angle in half, so that makes these angles congruent. 2 arcs. So we've marked up our picture. We're trying to prove that the smaller triangles, triangle ABD, is congruent to triangle CBD. So let's see what we're going to work with. If you want to take a few minutes and try to figure it out yourself, awesome. So do that and then come back. Okay. So our statement, obviously, again, we start with the givens. This here might not be every given on the same line. We're going to keep segments together. We're going to mark angles together. We're going to split them up as we're doing the triangle. So we're not going to put everything on one line. We're going to split it up. So we have angle or segment AB is congruent to CB, and AD is congruent to CD. That's our given. Awesome start. Line 2, we can say BD is congruent to BD. Why? Reflexive property. That's why we've learned it. It's the same line, so it has to be congruent to itself, but we have to prove that it's congruent. So we have to use the reflexive property. Line 3 now is our angles. BAD is congruent to BCD. Our other given. So we got three of our 4 givens away. We're actually not going to use the other given. We're not going to list it as a reason, as a given reason. We're actually going to use it kind of as a reason for why something else, which is this next line. We're told, I marked it, angle ABD is congruent to angle CBD. Those are the 2 angles formed by that angle bisector, segment BD, and that's the definition of angle bisector. So because we were told we didn't have to put it in, we can just use it as one of our givens. Does that make sense on that? Okay. Line 5 now, angle BDA is congruent to angle BCD. So now we're looking at the 3rd angles of our triangle. And that's the 3rd angle theorem. If 2 corresponding angles in each triangle are congruent, the 3rd angles in each triangle has to be congruent as well. So now we have all the sides are congruent, all our angles are congruent, so our triangles are congruent. Where is my thing? There we go. So triangle ABD is congruent to triangle CBD for the definition of congruent polygons. Does that make sense? This is a proof that you're going to see over and over again. Hint of foreshadowing, this might be the proof you see on the test, just with different reasons why it's true. There'll be something else we'll work on later on in this chapter. There'll be additional reasons why we can prove that those angles are congruent, or those triangles are congruent. Okay, some problems for you to work through. Again, take your time. I think it's 2 slides here, but it's 6 problems on your own. Yeah, actually in the proof too, work on the proof too. So we have all these to do. Try those, come back, enter your answers in Edpuzzle, and then come back and check your answers. Okay, so we're given on the first problem, we're told that ABC is congruent to triangle DEF. So we kind of look at it and say, okay, what do we got? What are we putting together? Okay, I think I can figure it out. All right, so we're trying to find the value of X. So X is on our long side, which is EF. So what we're trying to do is we're trying to find the corresponding part to EF. So EF is congruent to what side when we kind of look over here. And when we look at that, it's going to be this side here. It's going to be AC. We'll talk about it a little bit later on in this chapter, but when we kind of look at how it goes, that's the side it's going to be, because it's the side opposite the biggest angle, basically. This looks like my longest side here. So we're going to go with that side as my side, okay? So we're going to say AC. So then I know 2x plus y is going to equal 96.6. Whoops. No decimal point there. Let's erase that decimal point. So that's going to equal 96.6. But I have two variables in my equation, so now I got to figure out what does y equal. So y looks like we're going to be able to find the y from solving our angle. So here, if I kind of look at this, I'm going to go with my angle B here corresponds to angle B. So I can say 75 equals 2y minus 5. So y and 2y is going to equal 80. So y equals 40. Is this going to make sense? Yes, this will make sense. So we have y equals 40. So now I can go into my equation over here. I plug 40 in for y, so I end up with 2x plus 40 equals 96.6. Subtract 40 from both sides. 2x equals 56.6 divided by 2. X equals 28.3. So we have it. Y equals 40. X equals 28.3. Hope everybody saw that. This next problem was kind of like the rigid motion stuff. So these are all the transformations we worked on. I just kind of threw them in here so you can kind of see and piece together kind of what it is. So when we look at the rigid motions, so we look at our pictures, I have this angle and this angle have the 1 slash mark, so they're the congruent side. So if I look at it, I probably have to reflect if there was some kind of crazy reflection line in here. I'm trying to map this triangle here directly over the other one, so I have to reflect it. And then I have to translate it a couple points up to get it to completely fit over that. Does everybody see that? Number 4 is a little easier, because when I look at it, if I just reflect it over point N, they're just going to fit right on top of each other. Think back to the reflections on the graph that we worked with. That's the best example to look at it as kind of like a butterfly or bird. So that's what we're looking at there. And then if you wrote the congruent statements, you'd have triangle ABC is congruent to triangle DRS. Again, match up your angles with the angles. And then you have all the sides. AB is congruent to RD, AC is congruent to DS, BC is congruent to RS, and then all your angles, A to D, B to R, C to S. Make sense? Same thing with the other one. I think everybody can kind of do that. I'm not completely concerned about doing that. I'm more worried about the algebra parts. Like this next problem. Again, polygons ABCD and PQRS are congruent. I want to find the value of X and Y. What happens when we're kind of looking at this? If they're congruent, when we start looking at the spots, this is the way they're read. So my point P, I'm going to circle, and angle P and angle A are the corresponding angles. So when I'm trying to solve for X, I know right away 100 is going to equal 2X plus 4. So we'll subtract 4 from both sides. 96 equals 2X. So X equals 48. Does that make sense? Okay. And then I look at my sides. DC is the big long side. So that side corresponds to RS. So my equation there is 3y minus 3 equals 12. Adding 3 to both sides. 3y equals 15. Y is going to equal 5. Fairly simple, straightforward. They tried to mess you up because they gave you the two measurements, so you weren't quite sure which one. Just remember, the first letter of the name of the polygon is where you're always going to correspond. That's where they're going to correspond to. Make sense? Okay. The proof. Let's work on this proof. Again, mark up your angle. Mark up your picture. P is congruent to R, so one arc. Angle PSQ, so we're going to do PSQ, so this angle. 2 arcs. 2 arcs there because it's angle RSQ. PQ is congruent to RQ. PS congruent to RS. Kind of think through what you're going to have to do. It's looking like we're probably going to need a reflexive thing in there somewhere. We're trying to prove that the two smaller triangles are congruent. We'll start with our givens. Angle P is congruent to angle R. PSQ is congruent to RSQ. Given. Done. PQS is congruent to RQS because of the third angle theorem. If two angles are congruent, then the third one has to be congruent. PQ and RQ, PS is congruent to RS. That's our second given. Remember, we're splitting up the givens now. Do segments and angles separately. So then we have angle Q, or segment QS is congruent to segment QS, the reflexive property. So now we're told that triangle PQS is congruent to triangle RQS, the definition of congruent polygons. Does that make sense? Does everybody see that proof? Everybody good? Awesome. That is the end. Everybody have a good Thanksgiving. And I'll talk to everybody briefly tomorrow. I definitely want you to check in because I have to take attendance to make sure that everybody was there for the meeting. I'll go over any questions that you might have on this. And then we'll kind of go from there. So have a good Thanksgiving. I'll talk to everybody tomorrow.